Hello Tom, this is Mehlara and this is our group again for the last assignment. I'm going to focus on the collision detection of our code. So here in Collision Manager, we have an update function which calls the check functions that we have set up. And it calls it for every actor that we have. Those include check AABBs, AABB sphere, and AABB sphere 1. I'm going to tell you the difference between the two in just a moment. And also sphere. So more about check AABBs. It does a check between two cubes to see if the first one's minimum XYZ is less than or equal to second one maximum, and also first cube's maximum is more than or equal to B's minimum. Then it detects collision. And here we have this if statement that says if you haven't done it already, add B to the context of A and set the is colliding boolean to true. Then this part right here is for the purpose of keeping the cubes on the ground. This boolean here, when it's set to true in the cube, in its update function, it'll set the velocity of that cube on the y-axis to 0, so it doesn't move down like lower than the ground level. Then here we also set the position, of course, and if not, we set the boolean to false. Here we say if they're not colliding anymore, we're just going to reverse everything we did technically. Check AABB sphere does the check between a sphere and a cube. And the difference between this one and the next one is here we set the proper response for the sphere, and the second one does the same thing but for the cube. What it does is it calculates the closest point on the box to the sphere, and then we check to see if that distance is less than the sphere's radius. Then it means it's colliding. Then we do the same thing. Here is more of a response situation that Negin will cover. And we got the same thing here as well. And the last thing is sphere. We calculate the distance between the two spheres. Then we say if that distance is less than the total of the radii, the two radii combined, then it means they're colliding. And we're going to do the same repeated steps. Thank you.
Hi Tom, this is Negin and I'm going to explain to you the implementation of the 3D collision response. Here I should note that at first we used the formula that was in week 13. We found the collision normal, the relative velocity and the impulse and the friction impulse, but we noticed that the results we are getting, they are not that accurate, so we decided to switch to the formula that was in week 11, and as Spencer said, that would work for 3D. So here it is our implementation for response. We set the direction of the sphere or the cube when we detect the collision to the sphere mass minus box mass multiplied by sphere velocity over sphere mass plus box mass plus 2 times box mass multiplied by box velocity over sphere mass plus box mass, and then we set the speed of the sphere or the box to the magnitude of these the direction that we calculated. After that, in the sphere or box, we in the update function we set the acceleration to the gravity plus acceleration multiplied by delta time, and we set the velocity to the speed multiplied by direction plus acceleration the direction and speed that we calculated in the collision response, and then we set the position of the box or sphere to the velocity multiplied by delta time. Here, if we collide with the ground, we set the y component of the velocity to the 0. That was it. Thank you for watching.
Hi Tom, this is Negar, and in this video I'm gonna explain how we have implemented our object pool class, and at the end of the video I'm gonna show you a quick demo of our last assignment. So let's start with our object pool. In this class, in the store function, we create our bullets or our objects and add them to the list that we have. In the get function, we just return the objects that we just created. In the player behavior class, in the fire function, when the mouse button is pressed, we're going to activate the bullet that we have in the pool. In the sphere behavior class, we have a function which is called back to pool. In this function, when the lifetime of our bullet is done, we just deactivate it and add it to the list, and we reset all of its variables. Now, it was all that I wanted to show you for the object pool. Let me show you how it is represented. So as you can see, we have a bullet manager class, and all of these bullets are in the pool and they are not activated, but when I shoot, you can see, and when the lifetime is over, they just push back to the list and we deactivate them. So that was all for the object pool. Let's go for the demo. Alright, we are back with our demo. This is our start scene, and this is the environment that we had created for our project. We have implemented the collision detection and response between the bullets and the bugs that we have. Also, we have collision detection between the bullets and the floor, and also between the bullets and the walls, and between two spheres. If I can hit the spheres. Also, when I shoot, you can see the number of active bullets on the screen, and I cannot shoot anymore now because we only have 10 bullets in the pool. And when their lifetime is over, they're gonna be deactivated. That was all that I wanted to show you for our demo. Thank you for watching. Bye.